Earth, the Goldilocks Planet. Earth is a freaking miracle, and the best part is, it almost didn't happen. So you know how Earth is not too hot, not too cold, not a flaming gas ball, not a frozen rock, not raining acid like Venus or spinning like a blender on crack like Jupiter? Somehow, this little blue marble got it just right. And let's be honest, the universe, it didn't do us any favours either. It's freezing, boiling, radioactive, and mostly empty. Finding a planet like Earth is like finding the tickets of Eras tour last minute. The possibilities are pretty thin. One wrong tilt, one bad orbit, one missing ingredient, and this entire place could have been just another lifeless rock. So how did it happen? Why is Earth the planet that got everything just right, while the rest of the solar system is basically a no-go area? Let's break it down. The Goldilocks zone. You're a planet, floating in the dark, no second chances. You either land in the right spot or you're basically gone forever, orbiting in silence for the next few billion years. Too close to the sun and you boil. Too far and you're ice. But Earth didn't miss. It found that narrow little strip, the Goldilocks zone, where liquid water can exist, temperatures are just right, and life doesn't instantly regret being born. And let's be honest, Earth didn't earn this. It didn't plan it. It just happened to land in the one orbital parking space that wasn't trying to kill everything on it. And that changed everything. Because in this zone, water doesn't vanish. It doesn't sit locked in ice. It flows, rains, and steams. And that's how cells form. That's how fish crawl out. That's how you, sitting there watching this, exist. Venus didn't get that chance. It was too hot, so water turned to vapour. The vapour trapped heat, which obviously heat melted rock, and the whole planet basically gave up. And no one's blaming poor Venus, it just wasn't meant to be. And Mars is pretty close, but still no. It was too cold. Its water either froze or ran off crying after it lost its atmosphere. But Earth lingered in the right place. And it wasn't like Earth fought back or tried hard, it survived because sometimes the universe rolls the dice, and one random rock planet gets lucky. So Earth's in the right spot, but that alone isn't enough. Just because you've got the right seat at the table doesn't mean you're getting served. You still need the main ingredient, the one thing every living cell agrees on, the thing life can't even start without: liquid water. So we really need water. And Earth, it doesn't just have water, it's drowning in it. Before the forests, before the oxygen, before anything that even looked like life, there was rain. We're talking a non-stop, planet-sized downpour that lasted for millions of years. Rain that filled the craters, flooded the cracks, and turned raw rock into the first oceans. That was Earth's big moment. Because water isn't just pretty and Instagrammable, it's the engine. It carries, balances, dissolves, basically does everything. Without it, you have no chemistry, no evolution, no amoebas turning into fish, turning into people who argue on the internet. But here's what might shock you. The water that's here now, it's the same water from millions of years ago. It was recycled endlessly, through clouds, rivers, guts, glaciers, and tears. So we're probably drinking the same water that passed through the organs of a dinosaur. Who knows? And other planets, oh, they weren't so lucky. Mars had water, then lost it. Venus could have had water, but boiled it off. But Earth held on. And that one decision to hang on to the water changed everything for Earth. So Earth had the right spot, it had the water, and life was finally getting its act together. But there was still one not so tiny problem. The sun. Our life giver. Also a giant radioactive ball of fire. And if Earth didn't have a way to block that constant solar rage, everything alive would have been fried before it learned how to blink. Earth's core and magnetic field. And even now, beneath the forests and oceans and cities, Earth is burning, quietly and constantly. At the centre is a solid ball of metal, mostly iron and nickel, which is hotter than the surface of the sun, basically 5,000 plus Celsius. And it stays solid the whole time because the pressure down there is ridiculous. Surrounding this metal ball is a swirling layer of molten metal. This layer is also made of iron and nickel, but it's toned down with lighter stuff like oxygen and sulfur. And here's where it gets interesting. That hot swirling metal isn't just sitting there for decoration. It's moving constantly, and that motion does something absolutely incredible. It generates Earth's magnetic field, kind of like those little experiments you did in high school with a wire and a magnet, or if you're fancy, like the motor in an electric car. It's the same basic idea, just a million times bigger. You don't see this magnetic field, you don't feel it, but without it, you're done. That restless motion powers something we almost never talk about, but our life literally depends on it, and it's Earth's magnetic field. Think of it like the planet's personal force field. It wraps around Earth like an invisible cloak, and its one job is to keep space from killing us. Because space isn't empty, it's loud. The sun sends out solar winds at millions of miles per hour. Charged particles, radiation, plasma, just casually flying around out there, looking for a planet to ruin. Without a magnetic field, Earth's atmosphere would have been stripped away billions of years ago. We'd be dry and as good as dead, just like Mars. But lucky for us, Earth's core kept spinning, and the field held on. And thanks to that, we breathe, exist, and binge-watch documentaries about our own survival. And the coolest part is you can actually see this life-saving magnetic field sometimes. When solar particles hit the field just right, they get pulled towards the poles. They light up the sky in eerie waves of green, pink and violet. Yeah, those Instagram videos you see, that's exactly it. We call them auroras, but what you're really seeing is Earth's shield in action. Auroras. So let's say you're standing somewhere cold, real cold. Maybe Norway, maybe Alaska. Sky's dark, the air's quiet, and then there it is. A shimmer and then a ripple. Green waves twisting through the night like they're alive. Moments later, pink joins in, and then violet. The whole sky starts to move like a slow-motion fire. That's not just a pretty light show, that's a cosmic one-on-one fight, Earth versus the Sun. What you're seeing are auroras, created when solar particles crash into our magnetic field and spiral towards the poles. They should have scorched us, but instead, Earth redirects them, turning destruction into beauty. It's the only time you can watch the planet defend itself. So Earth has its shield, and its water, but it's not just a floating ball of ocean and magma. It moves, shifts, and breaks itself apart on purpose. And there's a very interesting reason why. Plate tectonics and ocean current. So just look down. You're sitting still, but the ground beneath you isn't. It's because Earth's outer shell is broken into massive slabs called tectonic plates. They don't float aimlessly, they grind, collide, stretch and sink, and every mountain, valley, continent, you name it, exists because of this quiet chaos. It's literally our planet breathing. Mount Everest formed when two plates crashed so hard the land folded upward. The Pacific Ring of Fire? That's just Earth venting steam through volcanoes and earthquakes. But here's the kicker. Tectonic movement doesn't just shape the surface. It recycles carbon, pushes nutrients from deep underground, and keeps the planet's interior from overheating. No plate tectonics would just mean you eventually lose your atmosphere. Just ask Venus. And that's not all. These moving plates help stir the oceans, and when oceans move, they become something else entirely, or in other words, currents. So Earth's crust is basically cracked like a giant eggshell, and those cracks are always creeping around, building continents and wrecking coastlines like it's their full-time job. But that movement does more than just make mountains. It stirs the pot. Let's see what happens when the oceans start moving too. Ocean currents. Earth's oceans aren't just sitting there, they're in motion, constant motion. Massive underwater highways of water travelling thousands of miles, no road signs, no brakes, and mostly no accidents. Warm water from the equator heads north, cold water from the poles sinks and slides south. The ocean basically runs a global conveyor belt, quietly redistributing heat like a planetary thermostat. Thanks to that, Europe isn't an ice cube. The tropics don't boil over, and fish, they get a one-way ticket to places they never would have swum on their own. Currents also help power the weather. Monsoons, hurricanes, gentle breezes, all of it gets a nudge from the ocean's invisible push. And the whole thing is driven by temperature, wind, salt, and a little help from gravity. Without ocean currents, the planet's climate would break down like a bad group project. Too hot in some places, too cold in others, and nothing working together. But here, everything's coordinated. Like the ocean got the memo, quietly holding the system in place, like that one underpaid employee in your office. So the oceans are doing their part, moving heat around, keeping the air swirling, helping Earth stay in place. But what about the air itself? That stuff we breathe? Yeah, let's talk about the atmosphere. Atmosphere and climate. You can't really see the atmosphere, but it's holding your life together, literally. Earth's atmosphere is this thin, invisible blanket wrapped around the planet. Not too thick, not too thin. Just enough to trap the right amount of heat, block the worst space radiation, and let you survive long enough to watch videos like this. It's 78% nitrogen, 21% oxygen, and a whole cocktail of gases that sound boring until they stop working and, well, you start choking. But it's not just there to help you breathe. The atmosphere is the weather. It rains, snows, storms and shines because of the way air moves, heats and cools. Without it, temperatures would swing from scorching at noon to frozen at midnight, every day. Venus has an atmosphere too, but it's like being trapped in a sauna with no exit. Mars has one, but it's so thin you need a full bodysuit just to blink. Earth's got the Goldilocks blend. Breathable, manageable, not trying to cook you alive. And it doesn't just sit there doing nothing. It helps balance oceans, land and sky, and on most days, it works. Tidal patterns. And on the subject of skies, do you know the moon is basically obsessed with the Earth? The moon doesn't just light up the night or inspire bad poetry, it pulls on Earth. Told ya, obsessed. Its gravity tugs at our oceans, dragging water back and forth in a rhythmic sway we call tides. So no moon would mean no tides would mean no coastal life, no nutrient mixing, and a lot less life on Earth. It even helps stabilise Earth's tilt. That means no wild climate swings or surprise ice ages every other Tuesday. So yeah, it just floats up there silently, but without it, things get weird, fast. So just to put things into perspective, Earth is in the perfect spot. It's got water, a magnetic force field, moving plates, ocean currents, breathable air, and a moon that doubles as a gravitational babysitter. Every part of it works together like a system that shouldn't work, but does. No other planet we know of comes close. Most are either frozen, fried, toxic, or spinning like they ate too many candies. And even with the James Webb Telescope scanning distant galaxies, we might not find another place like this for decades, or ever. So yeah, Earth's not just a planet, it's our planet, and it's one hell of a rare one. And if you want to know such cool things about Earth and beyond, why aren't you subscribed yet?